Hello friends, welcome back. In this module we will study biodegradable polymer. The examples of that are Dextron and nylon 2, nylon 6. So let's start with Dextron. Now what is Dextron? Dextron is a copolymer, that is a polymer formed by two monomers. Which are these two monomers? 2-hydroxypropanoic acid and 2-hydroxyethanoic acid. These monomers join to form a polymer by condensation polymerization, and the linkage present between these two monomers is ester linkage. The linkage is ester linkage. Now which are the two monomers used for Dextron? Yes, as we studied in definition, the two monomers which are used in this Dextron is 2-hydroxypropanoic acid and 2-hydroxyethanoic acid. Students, we know the monomers. So what are we waiting for? Let us start with the preparation of Dextron. So we take the molecule, the monomers which are there are 2-hydroxypropanoic acid, that is also called as lactic acid. In common words what we use is lactic acid. So 2-hydroxypropanoic acid, the structure will be a 3-carbon chain in which the terminal and end, that is the first carbon, is COOH, a carboxylic group, and at the second position of the chain will be a OH group. So let's draw the structure. It is C double bond O, OH group, the first carbon. The second carbon we have a hydroxy group, and the third carbon is CH3. The remaining valencies are filled by hydrogen atom. Let's take the second monomer, which is our 2-hydroxyethanoic acid, which is also called as glycolic acid, So the structure for 2-hydroxyethanoic acid will be the first carbon we have carboxylic group, that is C double bond O, OH group, and at the second carbon what we have is hydroxy group, that is OH group. The remaining valencies, yes, the remaining valencies are filled by hydrogen atoms, which is filled by hydrogen atom. So when we add these two monomers, lactic acid and glycolic acid, in equimolar solution, what do we get? There is an elimination of water molecule. Yes, it is a condensation polymerization, and there will be an elimination of water molecule out of this monomer. So H2O is removed out, and what do we get? A chain of O, CH, CH3, C double bond O, O, CH2, C double bond O. This is the chain what we get. When we take n number of such units, what will we get? A big molecule with 2n minus 1 water molecule eliminated out. This big molecule which is formed is called as Dextron. What is called? Dextron. If you notice here, the linkage which is formed between these monomers when they are joined is C double bond O, O, which is an ester linkage. It is an ester linkage. So here we understood Dextron. Let us start with our second example, that is nylon 2 and nylon 6. Now what is this nylon 2, nylon 6? It is a copolymer. So what is this copolymer? Formed by two monomers. So it is a copolymer of 2-aminoethanoic acid and 6-aminohexanoic acid, formed by condensation polymerization, and the linkage present between these two monomers is an amide linkage. The linkage is amide linkage, right? So which are the two monomers which are there in this nylon 2 and nylon 6? Yes, you all know the answer. It is 2-aminoethanoic acid and 6-aminohexanoic acid. So let's start with the preparation of this polymer named as nylon 2 and nylon 6. So the preparation, we take our first monomer, 2-aminoethanoic acid, which is also called as glycine. Yes, it is also called as glycine. So how will be the structure? Let's make ethanoic acid, that is CH2, C double bond O, OH, and at the second carbon atom what we have is an amino group, that is NH2 group. So we have C double bond O, OH at the first carbon atom. The second carbon we have our NH2 group, and the remaining valency are filled by hydrogen atom. Yes, it is filled by hydrogen atom. The second monomer which we add here is 6-aminohexanoic acid. 6-aminohexanoic acid, which is also called as omega amino caproic acid. Now how do we make the structure of this 6-aminohexanoic acid? We take a chain of 6 carbon atom. Since it's oic acid, it contains a carboxylic group at the first carbon. So we have COOH group. The remaining 5 carbon atoms are linked by a bond to form a straight chain. It will form a straight chain. And at the last carbon, that is 6th carbon, what we have? A amino group, that is a NH2 group. The remaining valency we filled with hydrogen atom. Yes, we fill this remaining valencies with hydrogen atom. Now, how do we write this big molecule in a condensed form? We first write our COOH group. The middle chain that contains a methylene group, 5-methylene group. How do we write that? CH2 in bracket with 5 outside the bracket, and an NH2 functional group at the terminal end. This NH2 group can also be written as NH with a H bond separated. What will happen when we mix this 2 solution of glycine and omega amino caproic acid? It is a condensation polymerization. So there will be an elimination of water molecule to give us H2O. Yes, it will give us H2O. And the chain which is formed is NH, CH2, C double bond O, NH, CH2, 5 and C double bond O. When n number of such monomers are taken, we get a polymer with 2n-1 H2O molecule. This polymer which is formed is named as nylon 2-nylon 6. If you notice here, the linkage present is C double bond O NH, which is an amide linkage. I hope you all understood the preparation of dextrone and nylon 2-nylon 6. Here we end our module. Thank you.